All right, good morning. We're going to talk today about direction fields, section 7.2. Sometimes these are also called slope fields. But the idea behind these is that there are times when we can't explicitly find the solution to a differential equation, either because we can't separate the variables completely to get all the y's on one side and all the x's on the other, or perhaps we have to subtract a y instead of dividing or multiplying. And so in any case, there are circumstances in which we cannot actually solve a differential equation and get y equals something. So in those cases, and in other cases as well, even in cases when we can find a solution, it's often instructive to look at the slope field. So the idea behind the slope field is this. Okay, say we have a differential equation like y prime equals x plus y. What we can do is we can pick points on the plane and we can plug in the x and y coordinates of that point and get a slope. Okay, remember that fundamentally y prime, right, the derivative of y, is the slope of the tangent line at any particular point, right? Remember, the derivative is the slope of the tangent line. That's old, old information from September. So what we're doing is we're letting the differential equation itself tell us some information about the solution. So notice on this picture that at the point 0, 1, where x is 0 and y is 1, that would give us a slope of 1. 0 plus 1 gives us 1. So we would, if we were trying to get a picture for the entire differential equation, we would pick many points on the plane and we would sketch these little short line segments that would indicate the slope. So this little blue line that you see there is supposed to have a slope of 1. It's hard to verify that because there's only one point labeled on the entire graph, but the slope of that line is supposed to be 1. So the way we would continue this, this is the same differential equation, but I've filled in a lot more points. What we can basically do is follow the curve. So here's I think this would probably be the initial point that we graphed with a slope of 1. So if we wanted to try to figure out what the solutions would look like that actually goes through the point 0, 1, we just kind of follow this slope line. So if you follow this up, we get to here, we see this slope line is maybe just a little bit steeper, and we follow it up and we see that we're between two lines, between these two lines. So those are a little steeper yet, and they take us on up to here. So it looks like if the curve goes through the point 0, 1, this line indicates that it points up this way, this line's still pointing up this way, and so on and so forth. If we go the other direction, if we go down, we get in between these 2 points, which look like they're actually flattening out. And if we kind of reduce the rate at which we're decreasing here, by the time we get to here, we see that these 2 lines are starting to point the other direction. So this curve might pass on up through here, and this set of straight lines, like we have a bunch of slopes here that all seem to be the same, that probably indicates that there's an asymptote there. So up in this direction we'd be going that way, and then passing through the point and coming this way, we'd be approaching this this asymptote. So we can kind of get a picture for what the solution looks like just by looking at all of these different little lines. And if instead of the point 0, 1 we wanted to start at some other point, maybe we wanted to start at -1, 0, well, that would be right on that asymptote. That might not be a good choice. Maybe 2, 0. Okay, here it looks like we're increasing very steep, and we follow the same kind of pattern, but we do it in a different place. So this idea of direction fields is just this. We're going to try to get a feel for what the family of solutions looks like by looking at the slopes of those solutions at various points on the plane. So what we might want to do is say we take something like this. Okay, now this is an example of one that we can't solve explicitly. Okay, because if we subtract y squared, now we have y prime minus y squared on the left side, and how do we take the integral of that? Well, we can't. So we might just want to sketch the solution, the slope field. So I know that I'm skipping a lot of steps. You're not doing any of this by hand, but this is the slope field for x squared plus y squared minus 1. So if I wanted to sketch the particular solution that goes through 0, 0, then I would start at 0, 0, and I would follow that along, and it looks like I'd have this kind of path on the right hand side, somewhere in that vicinity. And then if we start from this point and go to the left, we'd go up and we'd follow this down. So it looks like it'd have maybe a sort of a cubic function shape to it, which might make sense considering we have an x squared in there. It's a little unclear because the y squared does complicate things, and if you notice, down here we have horizontal tangents in a couple places, and so there's some kind of interesting things happening, but the one solution that we're interested in is the one that goes through 0, 0, and it would look about like that. And I think on my next slide, yeah, I actually have that sketched out. So so this is the idea behind slope fields. Okay, we're just looking at this field of little slope lines and trying to figure out, in general, what kind of behavior does the solution have. These kind of questions show up on the AP exam occasionally. They're not real popular in the last few years. This one comes from the 2005 exam. 2005 wasn't the last time that this showed up, but it was one of, it used to show up more, let me say that. So I can't tell you for sure whether or not it'll be on the exam, but this is an example of how it could appear. So I'm going to give you guys the opportunity to work this. I'm posting this in Classroom so that in case you're not seeing it well on the video, you can look at the PDF version of it. I want you to give it a shot. Okay, you've got 12 points for part A that you need to sketch the slope lines for. Okay, and as far as the AP graders are concerned, they don't have to be perfect, but if you have a spot that has a slope of 2, it needs to be steeper than the line that has a slope of 1. So, if you have a slope of 0, that needs to look pretty horizontal. And if you have a negative slope, it needs to be decreasing, and so on and so forth. It doesn't have to be perfect, but relative to one another, they should be, easy to see. This one is steeper than the other. This one's negative. This one's positive, etc. For part B, it says to, what does it say? Let f of x be the particular solution with the initial condition 1, negative 1. So that would be going through the point 1, negative 1. Write an equation for the line tangent to the graph of f at 1, negative 1. So basically, if you have found the right slope for 1, negative 1, you should be able to come up with that equation and then use it to approximate f of 1.1. And then in part C, we want to actually find the particular solution to the given differential equation. So you'll have to go back up to the dy dx equals negative 2x over y at the top and actually solve that. But part C is the first part where your points are dependent upon solving the differential equation. For this question, you could get points just by sketching the slope field and finding a tangent line. So those two things I think are well within everybody's grasp, and then solving that differential equation, hopefully. I know it's been a little while since we've done it, but hopefully you guys can give that a shot. I will post the solution to this probably Tuesday. I'll probably post this not the day of class, but the day after class to give you guys a chance to work it yourself, and then I'll post the solution. Your homework for this section is, in addition to working on that FRQ, just a few questions out of section 2. This isn't, I don't think this should be a real intense section. You're never going to have to sketch 50 slope lines for something, for me. But if you can sketch somewhere from 6 to 12 points, then you should be in good shape. So let me know if you have any questions, and good luck with this. I'll talk to you guys soon.